Welcome to an intro to limits of a sequence. The goal of this video is to determine whether a sequence converges or diverges. So if the terms of a sequence a sub n approaches a number L as n increases, then we can say the limit of a sub n as n approaches infinity equals L. And sequences that have a limit converge, and sequences that do not have a limit diverge. So let's take a look at some sequences. Here we have the graph of a sub n equals 1 plus 1 over n. We could take a look at the specific values of the terms of the sequence. When n is equal to 1, we'd have 1 plus 1 over 1, that would be 2. That's this point here. When n is equal to 2, we'd have 1 plus 1 over 2, that would be 1.5 or 3 halves, or 4/3, and so on. So if we take a look at this graphically, we might be able to conclude that the terms of the sequence are approaching 1, and therefore the limit of this sequence as n approaches infinity would be equal to 1. Also, from what we know about limits, as n approaches infinity, 1 over n would approach 0, and therefore a sub n would approach 1. Let's take a look at another sequence. Here we have a sub n is equal to 1 plus 2 times n. So again, if we wanted to generate some of the terms by hand, we would let n equal 1, 2, 3, and so on. So when n is equal to 1, we'd have 1 plus 2 times 1, that would be 3. That's this point here. When n is 2, we'd have 1 plus 2 times 2, that would be 1 plus 4, or 5. The second point here represents that term. And then when n is 3, we'd have 1 plus 6, or a sub 3 equals 7, as we see here. So notice that as n increases, the value of the terms increase as well. So it would appear that the limit as a sub n as n approaches infinity would approach infinity and therefore does not exist. So we would say that this sequence diverges. It's also true that if a sequence is always increasing or always decreasing, it's called a monotonic sequence. Let's go and take a look at one more sequence before we look at another definition. Here we have a sub n is equal to 2 times negative 1 to the power of n divided by n. Notice as n takes on the value of 1, 2, 3, and so on, it's going to alternate whether it's positive or negative based upon the power on negative 1. So this is called an alternating sequence. Let's go ahead and generate the first 2 or 3 terms. If n is equal to 1, we'd have 2 times negative 1 to the first. So we'd have negative 2 divided by positive 1. So when n is 1, we'd have a sub n equal to negative 2. That's this point here. When n is equal to 2, this will be a positive 1 now, so we'll have 2 times 1 divided by 2. That would give us 1 at this point here. Let's go and take a look at one more. When n is equal to 3, we have negative 1 to the third. That'd be negative 1 times 2. That's negative 2 divided by positive 3. So we'd have negative 2/3, and that's that point right here. As n approaches infinity, it does look like these terms will approach 0. So therefore it appears the limit of a sub n as n approaches infinity would equal 0, and therefore we could say the sequence converges. Let's take a look at a more formal way to determine the limit of a sequence. If the limit as x approaches infinity of f of x is equal to L, and f of n is equal to a sub n, then the limit of a sub n as n approaches infinity is equal to L. So what this is telling us is if we can define a function in terms of x, where f of n is equal to the formula for the sequence, and the limit of the function is equal to L, then the limit of the sequence is also equal to L as n approaches infinity. And it's also true that if the limit as n approaches infinity of the absolute value of a sub n is equal to 0, then so is the limit of a sub n as n approaches infinity. Let's go and take a look at a few more examples to determine the limit of a sequence. Here we have a sub n is equal to 3n minus 2 divided by n minus 1. So if we let f of x equal 3x minus 2 divided by x minus 1, notice that f of n would equal a sub n. So that means if we take the limit of the function as x approaches infinity, it will tell us the limit of the sequence as n approaches infinity. Well, this should be review. Since the degree of the numerator and denominator are equal to 1, this limit is equal to the ratio of the leading coefficients. So this limit would equal 3. And since the limit of this function is equal to 3, that tells us that the limit of the sequence, as n approaches infinity, is also equal to 3, and therefore the sequence converges. Now we have a sub n is equal to negative 2 plus negative 1 to the power of n. On this one, we may not have to define a function where f sub n is going to equal a sub n, because if we take a look at these terms as n approaches infinity, notice this term here will alternate between positive 1 and negative 1. If the exponent is even, it'll be positive 1. If the exponent is odd, it'll be negative 1. So when n is equal to 1, we'll have negative 2 plus negative 1, that's negative 3. When n is 2, we'll have negative 2 plus positive 1, so that'll be negative 1. And then when n is 3, this will be negative again, we'll back to negative 3. When n is 4, this will be positive 1 again, back to negative 1. So this sequence alternates between negative 3 and negative 1. Therefore, the limit as n approaches infinity of a sub n does not exist, and therefore this sequence diverges. This one might be worth graphing on the graphing calculator. First thing we should do is check to make sure that we're in sequence mode. In y equals, I've already typed in the formula for a sub n into u of n. N starts at 1. I'll go ahead and press graph. I've already adjusted the window because I knew the sequence alternated between negative 3 and negative 1. And if we press graph, if we press trace, we can see the function values in y. Again, just showing that this sequence does not converge, it just alternates between negative 3 and negative 1. Let's go and take a look at a couple more of these. Here we have a sub n is equal to natural log n divided by 5n. Let's let f of x equal natural log x divided by 5x. And again, notice that f of n would equal a sub n. So we'll take the limit of this function as x approaches infinity, and that'll help us determine whether the sequence converges or diverges. So in many cases, this just becomes a review of finding limits. As n approaches infinity, this is in the form of infinity over infinity. So to find this limit, we can apply L'Hopital's rule, which means we can find the quotient of the derivatives and see if we can find the limit of that instead of this original quotient. The derivative of natural log x would be 1 over x. The derivative of 5x would be 5. We could simplify this if we want, but as x approaches infinity, this approaches 0, and this is not affected by x. Therefore, this limit is equal to 0, so we can conclude the limit of the sequence as n approaches infinity is also equal to 0, and therefore converges. Here we have a sub n is equal to 1 divided by negative 2 to the power of n. And notice the power is going to determine whether these terms will be positive or negative, so this will be an alternating sequence. Remember earlier we stated that the limit as n approaches infinity of the absolute value of a sub n, if this is equal to 0, then so is the limit of a sub n. So what this tells us is that we can ignore the alternating sign of the sequence and consider the same function when all of the terms are positive. So the absolute value of a sub n would just be 1 over 2 to the power of n. So from here we'll let f of x equal 1 over 2 to the x and find the limit of this function. So we'll have the limit as x approaches infinity of 1 over 2 to the x. Now here we have a fixed numerator and an increasing denominator. This will always approach 0, and this implies the limit as n approaches infinity of the absolute value of a sub n must also equal 0, which in green tells us that the limit as a sub n as n approaches infinity is also 0. Therefore, this sequence converges. Before we go, let's go ahead and graph this original sequence to verify that it does converge and the limit is equal to 0. So go back to the graphing calculator, press y equals, and we'll type in our formula here. So we'll have 1 divided by, we're going to type in the original sequence, so negative 2 to the power of n Enter. Now let's go ahead and adjust our windows. Notice when n is equal to 1, we have negative 1/2. When n is equal to 2, we have 1/4. So we're going to have to adjust the scale on the y-axis. Let's set our y minimum to negative 0.5 and our y maximum to positive 0.5. Let's go ahead and press graph. It might be hard to see these points, but this sequence converges to 0 fairly quickly. If we press trace and then right arrow, you can see that the y values get small very, very quickly. And here it looks like it's at 0, but we can tell by these y values that it's not, but it is approaching 0 very quickly. Okay, that's going to do it for this video. I hope you found it helpful.